Hey everybody, welcome to General Equilibrium Part 2. If you didn't watch Part 1, go back and do that, because this won't mean a whole lot unless you do. Because we had a consumer, we had a firm, we had labor-leisure decisions, we had all sorts of stuff going on, and all I'm telling you in this video is, hey look, there's 7 equations, and here's the 7 things we're trying to solve for. So moving forward, what's going to happen in this video? My goal is to solve for XL and K as functions of prices, WRP lambda. Now, there are lots of ways you could do this. 7 equations means there is a ton of flexibility allowed to you as the person solving it. So I'm going to do it one way. Even this goal, solving for the quantities as functions of prices, that's just my personal preference. You could start by solving prices. You could just try to solve for everything at once. Doesn't really matter to me. I'm showing you how I would do it. Now the first thing I want to do, my personal preference, I like to combine the first order conditions for my consumer as well as the first order conditions for my firms. So I'm going to, for my first step, create a new equation by dividing equation 2 by equation 3, and that's going to give me something like this: alpha x over beta times 1 minus L equals W over P. And I'm going to call that equation 8. Likewise, I can do equations 5 divided by equation 6, and that's going to give me something like gamma k over delta L equals W over R. And I'm going to call that equation 9. Now, pretty much always when you're going to solve for this stuff, or I shouldn't say always, but when you have nice utility functions, it's always nice to combine these first order conditions, because this is a lot prettier than that and that. Like especially in this case where I do Cobb-Douglas, it comes out very nice. But anyway, let's see. Next thing I see a Q here and a Q there. That's going to be a really easy substitution. So I'm going to substitute equation 7 into equation 4. And that's going to give me that x is equal to L to the gamma, k to the delta. And I guess I will call that equation 10. Now, why am I numbering them? You don't have to. I find it's helpful. Like, it won't look like much in my video because I'm going to skip most of my algebra steps. But when you do a whole bunch of algebra on a page, it's nice to have these markers to say where are your solved equations and your important information. Now before I move on, let me do something to equations 8 and 9. I'm going to rewrite them just a little bit. I'm going to solve for L in both of them. In one case, L is 1 minus alpha px over beta w. And in the other case, it's L is equal to gamma k, well that's an ugly k, gamma k r over delta w. Those are just rewriting the same equations. This is equation 8 just the same as this is equation 8. They're the same thing. So that said, I'm going to set these two equal to each other to get k as a function of x. So I'm going to say substituting 8 into equation 9 gives me 1 minus alpha px over beta w equals gamma kr over delta w. And then I can rewrite that to give me delta over beta gamma r times beta w minus alpha px equals k. And I'll call this equation 11. Now, why did I do this? Well, I'm trying to figure out a way to substitute these equations in and out of each other to start to isolate things. Specifically, I want these things, XL and K. When I saw two L's, it was too tempting to want to substitute them and get rid of the L's. So let's try the next version, or the next step in my mind here. What if I substituted equation 8 in, let's see, equation 8 and equation 11 into equation 1. What was equation 1? Oh, that was the consumer's budget constraint. So this is going to be Px equals WL plus RK. Well, I've got a K and I've got an L in equation 8. So I'm substituting these results into each other. It's going to give me Px is equal to beta W minus alpha Px over beta plus delta over beta gamma times beta W minus alpha Px. Now buried in this equation, I've got an x there, an x there, and an x there, and I don't see any L's or K's. So if I solve this for x, I'll get x as a function of prices and parameters and nothing else. I like that. That was one of my goals for this video. So if I solve for this, now luckily the x's are all the same power and all that. So I'm just going to say x prime of prices, W, R, P, given parameters, alpha, beta, gamma, delta. This thing is equal to beta times gamma plus delta over price times beta plus gamma times gamma plus alpha delta all times W. Now, what do I have here? This was one of my goals. I got x as a function of prices. So awesome. I'm going to move on now. Now, later in part 3, I'm going to search for some x, I'm going to search for some x star, which is just a function of alpha, beta, gamma, delta. But that'll be in part 3. And I probably won't even show all the algebra for it, because that just gets ugly. And, you know, grad school is all about hazing and stuff, so I might as well let your teachers bully you a little bit. So let's call this equation 12. Now, what should I do next? I'm going to use this equation 12 again. I've got an equation for x. I'm going to substitute it in right here. Now, why don't I substitute it in here or there or somewhere else? It's all a matter of preference. I'm going to substitute 12 into 8 just because I think it's going to come out nice. Why do I think that, though? Well, I've got x as a function of prices. I want L and K as a function of prices. This equation here, L is a function of x and prices. If I plug in my x here, I will have L as only a function of prices. See, that's our goal. Again, I'm trying to remove variables. And so once I get a substitution that has less, it's worth making the substitution. All right. So that said, substituting equation 12 into equation 8. Let's go L equals 1 minus alpha px divided by beta w. So that's 1 minus alpha p over beta wx put x prime on there just for a moment so you can see what I'm thinking. And then I'm going to erase that, and I'm just going to start substituting in this big ugly equation. Times beta gamma plus delta over price times beta plus gamma plus alpha delta, all times w. Now, first thing I'm going to see here, that w cancels out there, that beta cancels out there, that p cancels out there, and we just got really lucky. This didn't have to go this way, but I got lucky here. I was looking for L as a function of prices and parameters, but instead I got L as just a function of parameters. Alpha gamma plus delta over beta plus gamma times gamma plus alpha delta. Look at that. That's not an L prime of all that stuff. That's just an L star, which is just a function of alpha, beta, gamma, and delta. So I was looking for it to be a function of prices and parameters. It's only a function of parameters. This is like extra good. L was done even for the end of the third. L was done even for the end of part 3. Which is awesome. Alright. Yeah, between you and me, I didn't expect that. I was solving through it before I made the video, and I was like, oh hey, it's done. And I thought about finding a different way to solve for it that would leave W, R, and P in it, but I decided not to, because that'd just be lame. That'd be purely for showmanship and showing less than I needed to. Alright. We've got L. We've got x. Notice I'm using x prime for when it's sort of solved, it still has prices, and I'm using stars for when it's completely solved. I guess I can rewrite that L though. Let me do that real quick. L star is equal to beta plus gamma minus alpha times gamma over beta plus gamma times gamma plus alpha delta. I don't know if you prefer this to that. It doesn't really matter. They say the same thing. Alright. There's one version of L star. There's the other. Last one I'm going to do for this video. What if we substitute equation 13 into equation 9? Now, why am I going to do this? 13 gives me L only as a function of parameters. Equation 9 gives me K as a function of L up in here. K and L and prices. So if I can remove this L and only put parameters in there, I'll have K as a function of prices. That was my goal. So to do this, or to substitute 13 into 9, I'm going to say K is equal to delta W L star over R gamma. And that's going to come out to be K prime of W R P given alpha beta gamma delta is equal to delta W times beta plus gamma minus alpha, all divided by R times beta plus gamma plus alpha delta. And that gives me a K, and that gives me a K prime as a function of prices and parameters, and I will call that equation 14. Cool, so we finally achieved our goal that we set out to achieve at the beginning. which is to get XL and K as functions of prices. We went a little past our goal because we solved for L as a function of just parameters, but we still did our goal. So in part 3, I'm not going to do algebra, but I'll show you steps that will help you to walk through it. I'll show you how I would go about solving for everything as just functions of parameters, because now well, the worst is behind us. So I hope this was helpful. If not, too bad. Good luck, guys. Thanks for watching. All that stuff. See you next time.